Today's lesson is an overview of geometry, and so we're going to go over 2D and 3D shapes. 2D and 3D shapes, of course, are found in our everyday environments, and so what they mean, 2D refers to two-dimensional shapes, and they're so named because they occupy two dimensions of space. They occupy length and width. And so when you think of 2D shapes, these are shapes that exist completely on paper. They're completely flat. All right, so examples of 2D shapes that you might encounter commonly, right, in education are going to be circles, squares, triangles, rectangles, pentagons, ovals, diamonds, octagons, hexagons, things like that. So if they are flat and exist on a flat surface, they are two-dimensional. They only have length and width. So they don't exist only on paper, but they exist primarily on paper or some sort of other flat surface. All right, and so some ways of identifying two-dimensional shapes, of course, is by the number of sides, the number of corners, otherwise known as vertices, and of course, whether they have length and width, okay? So if a shape has 4 corners, 4 sides, it's gonna be a square, or it could also be a type of parallelogram. All parallelograms have opposite sides, same length, and they all have 4 corners. If a shape has 3 sides, 3 corners, in all likelihood, it is a triangle. If it is flat, if it only has length and width. 5 sides and 5 corners, this is called a pentagon. Penta means 5. If it has 6 sides, 6 corners, it's a hexagon. Hexa means 6. 8 sides and 8 corners is an octagon. When you look at a stop sign is an example of an octagon. It has 8 sides. And if it has no sides or infinite sides, right, and no corners, it is a circle. All right, a circle does not have sides and corners in the traditional sense of other two-dimensional shapes. So in just going further into detail of what I just mentioned, we can identify 2D shapes by the following features: faces, sides, and vertices/angles. Also corners, that was in the previous slide. So a face is just the flat part of the shape. For example, a square has one face. A side refers to the lines that comprise the shape itself. Okay, so a square has 4 sides. I need to draw 4 sides in order to form a square. Vertices are just the corner points where 2 lines meet. And so if you look at a square and you count the number of corners or vertices, there are 4. And of course, angles refer to the measurement of a given vertice. So the angles of a square each measure 90 degrees. They are all right angles. So we know what two-dimensional shapes are. They're flat, they have length and width. I can identify them by the number of faces, sides, angles, and vertices. Three-dimensional shapes are a little bit different though. So 3D or three-dimensional shapes are so named because they occupy 3 dimensions of space. They have length and width, and they also have height. Height is what differentiates a 2D versus a 3D shape. 3D shapes are not flat, and they exist as common objects in our everyday environments. So as you can see here, some common examples of 3D shapes include spheres, cubes, pyramids, rectangular prisms, cylinders, cones. There's just an abundance of 3D shapes. So these are just more examples of 3D shapes. And then there's also a nice little diagram that lists some of the properties of 3D shapes. So let's go over what those are. Much like two-dimensional shapes, we can identify 3D shapes by the following features: faces, edges, and vertices and angles. So 2D and 3D shapes share faces and vertices. What makes 3D shapes different is edges. So typically when you have a two-dimensional shape, it only has one face, but a 3-dimensional shape has more flat parts, okay? So faces, again, still refer to the flat parts of a shape. So if I'm thinking of the 3-dimensional version of a square, that would be a cube, and a cube has 6 faces. It's actually shown right here. So it has 6 flat sides. Edges refer to the lines where 2 faces meet. All right, so this would be an example of an edge right there, as well as this, 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 and so on to the other parts that you can't really see by virtue of this diagram. So a cube itself has 12 edges. Vertices, of course, are the corner points where two or more edges meet. So in this case, again, this would be a vertice for a cube. So cubes in total have 8 vertices. There's 1, 2, 3, 4, 5, 6, 7, and then there's, of course, a hidden vertice that's on the other side where the back edges meet. And then they also have angles. You can measure the angle of a given vertice. So the angles of a cube still measure 90 degrees. They're all still right angles. All right, so we're going to go over these two worksheets. The first one on the left is we're going to identify the 2D and 3D shapes. So we're going to determine whether the shape shown is two-dimensional, has length and width, or if it's three-dimensional, it has length, width, and height, or that extra like pop-out factor. Now, I know that this is a little more challenging because these are all on paper, but we're going to assume that if they're drawn such that you can see edges and that they have multiple faces, that they are three-dimensional, okay? So I realize that can be confusing, but if they look like they're drawn 3D, they have faces, edges, we're going to count them as 3D. So number 1 is a cube. It's the example we just went over, and we know cubes are three-dimensional. Number 2 is an example of a hexagonal prism. And how do you know? It has a hexagon base. So it's actually a hexagonal pyramid. It has a hexagon as a base, and then of course it has edges and faces. So it is three-dimensional. All right, look at number 3. You probably recognize what shape that is. Is it two-dimensional or three-dimensional? Exactly, triangles are two-dimensional. Look at number 4. It's a rectangular prism, which is three-dimensional. Number 5 is a cylinder, three-dimensional. Number 6, it's a pentagon. It simply has length and width, therefore it is two-dimensional. Okay, it doesn't look like it has faces or edges, or additional faces and edges rather, because all two-dimensional shapes have one face. Number 7 is a square. A square is two-dimensional. Nice. And the last one, number 8, is it's a cone, and a cone is three-dimensional. Very good. All right, now let's look at to the right. We're going to identify the name of the shape shown. So number 1, I'll help you with. Number 1 might look like a square that's turned on its axis, but it is actually a rhombus. Okay, a rhombus is a type of parallelogram. So opposite sides have the same length. Number 2 is a square. Good job. Yeah, it's the previous example that we've gone over. Number 3, is it a trapezoid, a rhombus, or a rectangle? It is a trapezoid. Very nice. Number 4, circle, cube, or rectangle? It is a rectangle. Number 5, is that a pentagon, a hexagon, or a square? Here's a hint. Count the number of sides. There are 6 sides, therefore it is a hexagon. Number 6, is that an octagon, a rhombus, or a pentagon? Remember, octa means 8, so an octagon has 8 sides. Penta means 5, pentagon has 5 sides. So this is a pentagon. It has 5 sides. Number 7 is really straightforward. It is a circle, right? It only has length and width. It doesn't have that additional three-dimensional factor. Number 8 is a triangle. Very nice. Number 9 is a cone. That's right. It is three-dimensional. How do you know? It has an additional face at the bottom. It has a circular base. And then, of course, there is the cone shape around it, which it would be an additional face. And number 10 is a cube. Pretty straightforward. It is drawn such that it has more sides, more faces and edges. Therefore, it's three-dimensional.